Good morning. We're going to review for the third quarter exam, part 1. I'm going now to share my screen. Okay, sharing my screen and maximizing it. Let's begin. For number 1, you are inspecting a welded joint and notice that there are several small cracks near the toe of the weld. What could this be indicative of? Is it undercutting, overwelding, cold cracking, or slag inclusion? Again, in this situation, you notice that there are several small cracks near the toe of the weld. So it is the indication of cold cracking because there are several small cracks. Number 2, while performing an inspection of a completed weld, you observe a rough surface with irregular pits along the weld bead. What's most likely cause? Okay, for number 2, as you are doing inspection, then you observe a rough surface with irregular pits. Rough surface with irregular pits along your bead. So this is likely cause of gas porosity. Having humidity, cold air, so it will cause rough surface with irregular pits. Next, during a visual inspection, you notice that the weld has significant amount of slag left inside the joint, which is difficult to remove. What defect could this indicate? So in this problem, there is a significant amount of slag left inside the joint. If there are amount of slag left, it is one of the example of welding defect, which is slag inclusion. So the keyword here is the word slag. Amount of slag left inside the joint. So it is slag inclusion. 4, while welding, you notice that the molten metal is bubbling up from the weld bead, creating holes in the weld. What's the likely cause of this? So the keywords are bubbling, metal bubbling, and then creating holes. So if there is bubbles, if there are holes with your metal weld, it is an indication of having welded defect called porosity. 5, you are inspecting a weld and notice that there is an uneven weld bead with excess of metal on one side. So this could indicate what? Again, uneven weld, meaning not equal. And then there is an excess of metal on one side only. So there is a presence of welding defect called overwelding. Okay, only in one side. So this is uneven weld, not equal. Not equal, not all parts or not all sides. So there is the presence of overwelding. Next, during welding, you notice that the arc is unstable, causing the weld to be erratic and inconsistent. This might be due to, so this question is somehow repeated in another number. The problem here is the arc is unstable. Because of unstable arc, yeah, the weld it caused the weld to be erratic and inconsistent, not consistent. So this is because of what? Is it incorrect electrode type, too high of welding speed, insufficient with shielding gas, or poor electrode angle? So the correct answer is poor electrode angle. So the standard angle usually 0 to 15 degrees perpendicular to the base metal. Number 7, after welding, you notice some porosity in the weld metal. What might have caused this defect? If there is porosity in your metal, what is the main cause? Is it incorrect electrode size, high welding current, contaminated base metal, or excessive travel speed? Okay, it is because of contaminated base material. Maybe your metal was exposed to water, or maybe your electrode exposed to water, or maybe the working environment itself is an open area with humidity, with cold air. So that is the main reason why there is porosity with your weld metal. 8. You find that the weld exhibits small, round holes then scattered throughout the bead, particularly near the surface. What is likely cause? So the problem here, there are small round holes throughout the bead, okay? Particularly near the surface. It is because of gas porosity. Again, if there are small, if there are round holes, if there are bubbles, this is because of porosity, okay? Gas porosity. Next, after welding, you notice that the base metal around the weld has been severely discolored and brittle. What might have caused this? If your metal turns to other color after welding, then uh, it is because of excessive heat input. Because the tendency of changing the color is due to high temperature. Next, a weld has excessive undercut along the edge of the weld. What could be the most likely cause of this defect? The problem here, excessive undercut along the edge. So, what kind of defect? It is because of high welding defect, high welding speed, I mean. So, if your travel speed is fast, then there's a tendency of undercut along the edge because you are too fast. Okay, you are not focused on the right space. You are intended to weld because you perform high speed. There's a tendency to have undercut. Not all edges will be welded. Not all edges will be penetrated. You are welding a joint and you notice that the weld metal is cracking along the fusion line shortly after cooling. What defect might this indicate? So the problem here, there is a cracking along the fusion. Crack. Okay? Meaning, your bead, your fold weld is not solid. It's not strong enough because there is a crack present. Okay? You notice that there is a crack along the fusion line after cooling. So this defect is indicate what? Called cracking because the crack was noticed after cooling. Next, during an inspection of a weld, you notice that the weld surface is uneven with noticeable depressions along the bead. This is likely caused by, is it gas porosity, under welding, lack of fusion, or over welding? So the problem here, there is uneven, okay, uneven depression along the bead, meaning not equal, not proportion. So after you weld, after the inspection, you notice that the surface of your weld metal is uneven. So is it because lack of fusion? Because if there is enough or correct fusion, then it is even or equal in the surface of your weld metal. But then since you notice that there is uneven, maybe because of lack of fusion. Next, a welded joint shows visible signs of localized cracking near the heat-affected zone. What might be the cause of this defect? So what happened? There is crack, okay, where near the affected zone. So this is because of hydrogen and those cracking. Next, you're performing a post-welding inspection and notice that the weld bead has significant surface roughness and inclusion. What could be the probable cause? The problem number 14, you notice that there has surface that is roughness and inclusion. Okay, that's the defect. So is it because of what? Cold cracking, incorrect angle, lack of shielding gas, or excessive travel speed? If there is roughness and inclusion in the surface of your weld material, it is because of excessive travel speed. You're too fast. Okay? During welding, you notice that the weld pool has a missing sound and the weld metal is bubbling. What defect? If there is a bubbling, you already know. If there is a hissing sound, These are the keyword: hissing sound, bubbling. So this is because of porosity. Okay, the defect is what we call porosity. While inspecting a weld, you find a deep groove or depressions along the fusion line. This could be an indicative of, okay, in number 16, there is a deep groove or depressions along the fusion line because of lack of fusion. Okay. Again, the keyword here is groove depression, fusion line, groove depression along the fusion line. So the problem is lack of fusion. You notice that the finished weld has numerous small cracks in the heat-affected zone, especially near the base metal. What defect does this suggest? It is almost the same with the previous question. The problem here, presence of small crack near the affected zone or near the heat-affected zone, the area where you weld. So this suggests that this defect is because of hydrogen-induced cracking. So the problem here, numerous small crack because of hydrogen-induced cracking. Okay, cracking. That's the keyword, small cracks, cracking. You are welding a low alloy steel, and upon inspection, you notice that the weld has numerous pinholes along the surface. This is most likely caused by, okay, the problem here, numerous pinholes along the surface of your metal. Okay, porosity. Keywords pinhole. Okay, that is because of porosity. During welding inspection, you notice that the edge of the weld are uneven, showing noticeable ridge on one side. What is a sign of? Here, the situation is there is uneven, okay? Uneven in the edge of your weld. Then, you notice that there is a ridge on one side. This is a sign of overwelding. Overwelding, okay? Uneven, then you notice ridge on one side. Almost the same with the what do you call that? Incomplete incomplete fusion. Here, the only difference is that in overwelding, there is you notice that the edge of the weld are uneven, and another keyword here, ridge on one side. That makes it different uh, from incomplete penetration, because in overwelding there is a noticeable ridge on one side. Number 20, a welder reports difficulty in maintaining a steady arc, and you observe inconsistent bead formation with areas of undercut. So the problem is the welder finds difficulty in maintaining steady arc. Again, when we say arc, it is the distance between the tip of your electrode from the surface of your metal. So what's the problem? The difficulty in maintaining, the difficulty of of maintaining arc, and then consistent bead formation. So it is because of all of the above. Because of low welding current, because of too high of travel speed, incorrect electrode angle. So the correct answer is all of the above. During inspection, you find that there are cracks in the weld bead that appear in a straight line along the entire length. So here, there is a straight line crack after you weld. Okay, you find that there are cracks in the weld bead that appear in a straight line along the entire length. So it suggests that there is hydrogen induced cracking. So in every time you observe or notice with your metal that there is a crack that appear, especially in a straight line, it is because of hydrogen induced cracking. Next, you're inspecting a weld and see areas where the molten weld metal didn't fuse properly with the base material. This could be a sign of porosity, lack of fusion, slag inclusion, or overwelding. Here, the problem is the molten metal or the molten weld metal didn't fuse properly. So, if didn't fuse properly, it is because of lack of fusion. The keyword here, fuse. Okay? Did not fuse properly So the correct answer is lack of fusion. Keyword fuse. After completing a weld, the base metal has discolored in the heat affected zone. Almost the same with the previous question. And there's visible cracking in the weld. So the problem here, discolored in the material, discolored in the plate metal, and visible cracking in the weld. So this is because of excessive heat input. You put the machine into high voltage or high amperage. So that cause of changing the color of the metal and then visible cracking in the weld. Too much excessive heat input. Upon inspection, you find a welded joint that shows sign of undercut. Okay, there are signs of undercut along the edge of the weld. It suggests that excessive welding current. Sometimes you must be uh sometimes you must check carefully because there are some signs that almost the same with the undercut and overwhelmed. So the only the so in this situation, there are signs that undercut along the edge of the weld. So it is because of excessive welding current, too much amperage. Next, a welder noticed that their weld has fish eye appearance, with small round holes visible on the surface of the bead. So the keywords here, fish eye appearance and round holes visible on the surface. Porosity. Okay? Porosity, small round holes, and then fish eye appearance. And it has small holes. This is because of humidity, cold air, or the material, the weld metal, the electrode may be exposed to water. And then fails to do preheat, or maybe they forget to put the electrode in the electrode oven. So that caused porosity. So the keyword here, fish eye and small round holes. So that's the end of our review for the part 1 and third quarter.